Hi guys, so this is a new video on differentiation under Math SL. We shall continue with review questions, and this is the second video in this series. It is of difficulty level 2, so this is slightly more difficult than the previous video. However, it still lies within the range of doable questions. I shall tackle the 3 questions on the screen in front of you, and I shall begin with question 1 shortly. So the first question came in paper 1, May 2008, time zone 1, question 8. Kindly take a minute, attempt to solve, and the answer shall follow through shortly. So in question A, you are required to find f dash of x, given that f of x is this function. Let's take a look. This is simple differentiation. 1 over 3x cubed plus 2x squared minus 5x becomes x squared plus 4x minus 5. In question B, you are required to find the x coordinate of M, given that M is a maximum point. So let's take a look. Of course, a maximum point is a point where the slope is 0, so we are going to solve f dash of x equals 0. So since M is a stationary point, as we said, f dash of x equals 0, hence we shall set this equation to 0, and we can solve this manually, factorization, or using the quadratic formula. Anyway, the x coordinates, the possible x coordinates are -5 and 1. However, using the image of the graph, we know that point M lies in the negative x domain, hence the value of x has to be negative. Hence, I shall choose x equals -5. Next, I'm required to find the x coordinate of n, knowing that n is a point of inflection, and we know that at the point of inflection, f double dash of x equals 0. Hence, we need to find f double dash and set to 0. So we find f double dash by differentiating f dash, so this is f dash. Hence, f double dash is 2x plus 4, the derivative of the red equation above, and we set this to 0 and x equals -2. Finally, in question D, we are asked to find the equation of L, where L is the tangent to the curve of f at 3, 12, and we want to write the equation in the form y equals ax plus b. So to get the equation of line L, we need a point and a slope. We are given the point in the question as 3, 12. In order to get the slope, I shall evaluate f dash of x when x equals 3, which is the x coordinate of my given point. So I shall just plug 3 into this equation right there instead of x, and I've done just that, and I found the slope to be 16. Having the point and a slope, I can easily use the point-slope formula to get the equation of the line, but I have to do some further simplification. As you can see, I've done this right there and there, so that I arrive at a final answer where y is on one side and isolated, hence getting the equation in the form y equals ax plus b. So take a minute to write this down if you will. I shall begin the second question shortly. So the second question came in paper 1, May 2017, time zone 1, question 6. Kindly take a minute, attempt to solve, and the answer shall follow through shortly. So make sure you read the question carefully. This is not the graph of f, this is the graph of f dash. And you are told that the graph of f dash has a local minimum at A a local maximum at B and passes through 4, negative 2. In A, you are told that the point P4, 3 lies on the graph of the function f. Bear in mind that it does not lie on this graph. It lies on the graph of the function f, which we cannot see here. So in I, you are asked to write down the gradient of the curve of f at P. So the gradient of the curve of f is found by evaluating f dash. So since we want the gradient at P, we want the gradient when x equals 4. And you don't have an equation here, so you have to resort to the graph. When x equals 4, what is the value of m, the gradient? Or what is the value of f dash? So when x equals 4, the value of f dash is negative 2, because y here is the graph of f dash. So y here is the value of f dash when x equals 4. Hence the gradient at P, where x equals 4, is negative 2. In double I, you are required to find the equation of the normal to the curve of f at P. So we need a point and a slope. You are given the point P right there, and you found the slope in I. So let's see how to solve this. So as we said, the slope is negative 2, which we have obtained from the graph, and we have a point on the graph of f, which is 4, 3, not 4, negative 2, this belongs to f dash, 4, 3, which belongs to the graph of f, so watch out. So now that we have a slope and a point, of course, we want the equation of the normal, so we have to change the slope. The slope of the curve is negative 2, so the slope of the tangent is negative 2. Hence, the slope of the normal is positive 1 over 2. You flip and you switch. Hence, the equation of the normal is y minus 3, which came from this 3, equals half, which is the slope of the normal, times x minus 4, which came from this 4. Hence, this is the equation of the normal. In question B, you are required to determine the concavity of the graph of f when 4 is less than x, which is less than 5. So in the interval 4 to 5, you are required to determine the concavity of the graph of f and not f dash. This has nothing to do with f dash. This has to do with f, not the drawing in front of us. So the concavity of the graph of f comes from the state of f double dash. So we need to know whether f double dash is positive or negative in the required domain. If we manage to find that out, we can determine the concavity. So how do I figure out the state of f double dash in the region 4 less than x less than 5? By observing the state of f dash from the graph. So in this region from 4 to 5, what is happening to f dash? Since f dash is increasing right here, f dash, the curve in front of me, is increasing. As x increases, y increases. So since f dash is increasing, hence f double dash is positive. So because f double dash is the dash of f dash, it's the derivative of the derivative. And we know that if f is increasing, then f dash is positive. Similarly, if f dash is increasing, then f double dash is positive. So since f dash is increasing, hence f double dash is positive, and hence there is an upward concavity in the graph of f. Graph of f is upwards concave in this region. So take a minute to copy the answer down if you will, and I shall begin question 3 shortly. So the third question came in paper 2, November 2013, question 7. Kindly take a minute, attempt to solve, and the answer shall follow through shortly. So you are given the graph of a semicircle represented by this equation f of x equals root 6x minus x squared in this domain 0 to 6, and there is a rectangle inscribed within the circle or drawn within the circle, and you are given that OP equals x and you're required to find PQ in terms of x. So this requires some thinking. Since this graph is symmetrical around the middle, if this part right there is x, then this part is also x. Hence, PQ is the total, which is 6. Subtract, and we shall subtract from this total two x's, one for this x and another for this x. Hence, PQ equals 6 minus 2x. This is not very straightforward, but it's a tricky question. So, in double I, you are required to write an expression for the area of the rectangle. The area equals the length, which is 6 minus 2x, and this width right there. The width is given by the vertical distance between S and P, which is the vertical distance between S and the x-axis. This vertical distance is given by the value of y, and we know that the value of y at any point is given by this equation. Hence, the vertical distance shall always be root of 6x minus x squared. Hence, the area is given by 6 minus 2x, which is the length, multiplied by root of 6 minus x squared, which is the width. And here I've just rewritten it in terms of power half to assist me if I need to play around with it algebraically in future questions. So this is my answer, this is my expression for the area. Next, in question B, I want to find the rate of change of the area when x equals 2. We know that rate of change corresponds to y dash, or in this case a dash. So I want to find the value of a dash when x equals 2, and luckily there is a calculator function that can help me do that. So I've written down the expression for the area on my GDC. So there is this component, 6x minus x squared to the power of half, multiplied by 6 minus 2x, which is this component. Next, I shall adjust my window. I've been given in the question that it extends from 0 to 6 in terms of the domain. And in terms of the range or the y values, I shall have to use trial and error until I get an appropriate picture of the curve. Next, I shall click on trace, and there is my curve. I want to get y dash when x equals 2, so I shall press on second, trace dy by dx, and I shall enter 2, and the calculator tells me that the slope when x equals 2 is negative 4.9497, or just negative 4.95. In double I am told that the area is decreasing for a less than x less than b. Find the value of a and of b. So let's check this out using the GDC. So this is the graph of the area, and obviously it decreases from this region to this region. And I can get these 2 points using the calculator functions for maximum and minimum. So second, trace, find maximum, provide a left bound, and then a right bound, and then a guess. And the maximum is at 0.878. So this is the beginning of my region where the function is decreasing. To get the other point, I shall press on second, trace, minimum. I shall find a left bound for the GDC. So I shall drag the cursor to the left of my minimum, and then to the right of my minimum. And finally, I shall provide a guess. And the calculator tells me that the minimum is at 5.12, This is the end of the region where the area is decreasing. So you would be expected to provide this answer in the exam, but this is not the correct answer, unfortunately, because even though graphically the function is decreasing from 0.88 to 5.12, realistically speaking, there is no such thing as a negative area. So after this point, the graph is irrelevant because the area does not exist in negative values. Hence, the part where the area is actually decreasing is from this maximum point up until this point where the area becomes 0. And this point is at x equals 3. So we can actually check this out using the calculator to make sure. I shall press on second, trace, find the 0 value. I shall drag the cursor to the left of my 0 value and then to the right of my 0 value and then around my 0 value, and the calculator tells me that when x equals 3, y equals 0. So this is the minimum value of the area. Hence, the area is decreasing from 0.88, but only up till 3. So this is my correct final answer, and to be very honest, this is a mistake that most of you would be willing to make. You're allowed to make this mistake because it's very tricky in the middle of the exam to focus on the fact that the area cannot be negative. You would be inclined to just write the range of values as such. So this is something that is kind of your right to make. But anyway, this is one of the trickier questions. I hope you have understood it after the explanation. And this concludes our video. I hope you have found it useful.